So we are going to prove the Pythagorean theorem. So what this theorem actually is? Okay, so I will just try to explain it like this. Suppose we have a right angle triangle and this right angle triangle is having sides of length A, B and C. This length C is called the hypotenuse of the right angle triangle. So basically what the theorem says is A square plus B square is equal to C square. So we have come across this theorem, we might have come across this theorem many times in our life. So let's see about its proof, how this theorem comes up and what is the proof and what is the validity of this theorem. So guys, believe me or not, we have over hundreds of proofs for this single theorem, over hundreds of proofs, believe me. But I will tell you today the most simple of them all, which is best understandable. To prove this, I will first construct one square and since this is a square, all the four sides will be having equal length. So suppose it is of length x, where x is equal to a plus b. Just suppose it is of length a plus b, because we are now going to split this in this ratio a plus b. So let me choose another color. Yeah. So now let's split all the sides of the square. I'll split up it here so that upper length is of A and down length is of B, so that A plus B still remains x. Similarly, I'll split this row also so that this length is A and the remaining length is B, and join A to A. Again I will split this row also so that this length is A and this length is B. Again I will join A to A, and again I will split this last row, this last line, this last side of the square of length A and B, join A to A and join A to A. So we got a rectangle inside this square. What this rectangle is, I say it is also a square. Why? So you can see these are all, we have four right angle triangles of side length A and B. So since all these right angle triangles are exactly same, I'm not saying similar, they're exactly same, I mean they're having the two sides of length A and B, and obviously it is a right angle triangle, so obviously the hypotenuse will be of the same length, and I will say that the length of the hypotenuse will be C. So this is how the internal rectangle that we got, that is also a square, and we have one external square also. So if you look at this, we can say it's something like this: area of outer square is equal to area of inner square plus area of the four triangles. Does that make sense? Because the area of the external triangle encompasses the area of this internal square and the 1, 2, 3, 4, the four triangles. So if you look upon this very carefully, the area of the external square is equal to x square. So this is nothing but A plus B of a plus b whole square, and this is equal to or equivalent to area of internal x square c square plus area of the four triangles, and all the four triangles are equal, so I'll just say 4 into area of a triangle is half into a into b. This is how we define the area of the right angle triangle. So let's comment here, and it's equal to a square plus b square plus 2ab is equal to c square plus 2ab. So 2ab is cut down, and we are now left with a square plus b square is equal to c square. So this is what we have to prove, and we have raised it. So this is the easiest and the most simplest proof of the Pythagoras theorem. Thank you.